Am I audible?
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
Today, I will take 1 hour class right now. Okay. After that, I will take a break. I have to go outside, and then I will take another class. Means after half an hour, 45 minutes break, then I will take another class. Okay. So, I'm starting. So, today I will teach relational algebra. Okay. So, relational database systems are expected to be equipped with query language that can assist its user to query the database instance. There are two kinds of query languages, relational algebra and relational calculus. Okay. So, for each and every database, we require a query language. By that, we can retrieve whatever data we have into the database. Okay, so a query language is a essential part of any database. Okay, so there are two types of query language. One is relational algebra, another is relational calculus. So in this chapter, I will discuss about relational algebra. In database theory, relational algebra is a theory that uses algebraic structure with a well-founded semantics for modeling the data and defining queries on it. Okay, and this theory has been introduced by E.F. Codd, who have proposed those famous Codd rule. Based on that, nowadays we got relational database. So this is also proposed by Codd. Okay, E.F. Codd. Now, so it's a theory. Another thing is a theory. Okay. Okay. Now, the main applications of relational algebra is to provide a theoretical foundation for relational database. Okay. So it is not doing any practical thing, relational algebra. Okay. So see, by means of relational algebra, we can write different types of queries, but those queries is on pen and paper. We cannot write those queries in computer. So what it is doing, it is giving a theoretical foundation for relational database. Okay, particularly query languages for such database, chief among which is SQL. Okay. So you cannot write relational algebra, whatever query you will get by means of relational algebra, you cannot write those things directly into the database. You cannot apply them. Okay, it is giving a theoretical foundation for relational database, especially to SQL. Now, relational database store tabular data represented as relations. Okay, that we know. So in relational database, relations are the most important thing, and that is nothing but tabular data. Or those are nothing but tabular data, means tables. Tables are known as relations that I have told repeatedly. Now, queries over relational database often likewise return tabular data represented as relations. So if you write queries on relational database, as an output of that query, we get relation. So input is relation, output is relation, means input is table, output is also table. Okay, the main premises of the relational algebra is to define operators that transform one or more input relation to an output relation. Okay. So what relational algebra is doing? Relational algebra is defining operators which will transform one or two relation into an output relation. Okay. So see, one important thing, that input may be more than one relation. Okay, but output is only one relation. Okay, and relational, by means of relational algebra, we can define some operators which will do that. Okay. Now, it's what I have told earlier, that there are two types of language.
স্যার আগে স্লাইডটাতে আপনি বললেন না যে ট্যাবুলার ডেটা, ওগুলোকে কি টাপল বলতে পারি?
টাপল মিন্স রেকর্ড, একটা রো। একটা রো মিন্স টাপল। অনেকগুলো রো নিয়ে একটা টেবিল হয়, that means a relation, and then we can say that type of, if in a database there are a lot of relations, so in that case we can designate them as a tabular data. Tuple means rows.
আচ্ছা
স্যার ট্যাবুলার ডেটা রোজ আর কলাম দুটোই থাকবে?
বুঝতে পারলাম না, আর বলুন।
স্যার ট্যাবুলার ডেটা কি ম্যাট্রিক্স আকারে হবে, মানে রোজ আর কলাম দুটোই থাকবে, তারপর শুধু রো থাকে?
The tabular data means data in table form, so there will be row and column.
কলাম, হ্যাঁ, এস
দুটোই থাকবে।
আচ্ছা স্যার।
Okay. Now, what I have told earlier, that there are two types of language. One is procedural language and non-procedural language. So, relational algebra is a procedural language. Okay. In relational algebra, there are 6 basic operators. What I have told here. The main premises of relational algebra is to define operators. Now, in relational algebra, there are 6 basic operators. Okay, these are 6 basic operators of relational algebra. Okay, other operators of relational algebra can be derived from this operator or by this operator. Okay, these are basic operators. These cannot be derived from other operators. Okay, so select cannot be derived from by project, or project cannot be derived from select, like that. So these are basic operators. Okay. Now the operator take one or more relation as input and produce a new relation as a result, that I have told earlier. Okay. Now I will describe each and every basic operations. Okay, but with examples. Okay, so suppose we are having a relation R. Okay, now these are attributes. A, B, C, D. Columns are attributes, and these are records or tuples. So number 1 tuple, number 2 tuple, number 3, number 4 tuples, like this. Okay. Now, from these tuples, means there are 4 tuples. Okay, from these tuples, we can select some tuple based on some condition. Okay, now the condition is A equal to B and D greater than 5. So where A equal to B? So here A equal to B. Okay, so okay, fine. Then D greater than 5. D greater than 5. Okay, fine. So first tuple will be selected because it satisfies both conditions. So first tuple is there. Second tuple, A not equal to B. So forget about that. Now A equal to B. Okay, find beta beta. Now 12. Now D not greater than 5. So this will not be selected. Okay. Now fourth tuple A equal to B. Okay. Then D, that is 10, is greater than 5. So that will be selected. So this is a select operation. Okay, this is the notation for select sigma, and this is the conditions by which we are selecting tuples, and then we are giving the relation name. Okay, so select operation select some rows from relation. So see here, among 4 tuples, we are selecting 2 tuples by means of select operation. Is it clear?
Sir, in that selection symbol, that sigma A equals to B, what does that upward cap means?
And. This is one condition, A equal to B. Second condition is B greater than 5. And. This is and. Both conditions must be satisfied. Okay, clear? Now see notations. So sigma P R. Okay. Now sigma means selection operation. R means name of the relation. P means it is called the selection predicate. Okay. So here P means this A equal to B and D greater than 5. This whole thing is known as P. Okay. Now this is defined as sigma PR is tuples belongs to R and PT. P is a formula, is propositional calculus consisting of terms conducted by and or not. Okay. So in the formula of P, we can use and operation, or operation, not operation, and it is a propositional calculus. Okay, you will study this propositional calculus in AI. Okay. So the term is one of the attribute, okay, or constant. Okay. Now OPR, this means operations are equal to, not equal to, greater than, less than. Okay. So suppose in a bank database there are a lot of accounts. Okay. Now for some account, the account located at Perich branch. Okay. Now there may be other account from other branch. Now if you are interested about the account of Perich branch only, then you have to select those rows. So in that case, you have to write in this way: sigma branch name Perich within bracket account. Okay. Is it clear to everybody? Select operation.
Sir, many students are messaging in the group. They are unable to join.
1 minute. Okay, so is it okay for everybody?
So selection একটু বলে দিন। স্যার সিলেকশন প্রেডিকেট ওই জায়গাটা একটু বুঝতে পারছি।
P, এই যে Pটা, P মানে কি? এইখানে P মানে হচ্ছে এটা A equal to B and D greater than 5. So this whole thing is known as predicate.
আচ্ছা।
এটাকে একটা টার্ম আছে তো, সেইটাকে বলে predicate, selection predicate. আর কিছু না, এটার নামটা তাই, পি মানে প্রেডিকেট। প্রেডিকেটটা কিভাবে করা যেতে পারে? প্রেডিকেটের মধ্যে কিছু টার্মস থাকতে পারে, ঠিক আছে? Those terms will be connected by means of and or not. So here in this case we are using and.
Yes sir.
ঠিক আছে? আর টার্ম গুলোর মধ্যে is one of this attribute থাকতে পারে।
Yes sir.
attribute গুলোর মাঝে অপারেশন থাকতে পারে, or it may be constant। ঠিক আছে?
and অপারেশনের আগে ওটা অ্যাট্রিবিউটের আগে কনস্ট্যান্টও থাকতে পারে।
এখানে দেখো এটা কি a আর b দুটোই হচ্ছে অ্যাট্রিবিউট।
হ্যাঁ,
ঠিক আছে, মাঝখানে হচ্ছে অপারেশন হচ্ছে ইকুয়াল।
অপারেশন
ঠিক আছে, d টা হচ্ছে অ্যাট্রিবিউট,
হ্যাঁ,
মাঝখানে হচ্ছে অপারেশন আর 5 টা হচ্ছে
কনস্ট্যান্ট।
তাহলে এটা বুঝতে পারলে কি লেখা আছে?
হ্যাঁ স্যার, ঠিক আছে।
আর মাঝখানে অপারেশন গুলো হচ্ছে এইগুলোর মধ্যে যে কোনো একটা হতে পারে।
আচ্ছা, ঠিক আছে।
ঠিক আছে, similarly if you want to select the account for page branch only, then you can write sigma branch name equal to page, okay, from account relation।
আচ্ছা স্যার।
অন্য ব্রাঞ্চ নেম, অন্য ব্রাঞ্চের অ্যাকাউন্ট গুলো আসবে না এখানে সিলেক্ট করলে, কিন্তু তোমার অ্যাকাউন্টের মধ্যে সব ব্রাঞ্চেরই অ্যাকাউন্ট আছে, সেখান থেকে খালি পেজ ব্রাঞ্চের অ্যাকাউন্ট গুলো সিলেক্ট হয়ে যাবে।
ঠিক আছে
ক্লিয়ার এভরিবডি?
স্যার এক্সপ্রেশনটাতে টি আর পিটি টা কি কি বোঝাচ্ছে?
টি মিন্স টাপল। ঠিক আছে, আমি যখন সিলেক্ট করছি তখন কি পাচ্ছি? আমি তো আগে চারটে টাপল ছিল, তার থেকে আমরা দুটো টাপল সিলেক্ট করলাম। ঠিক আছে, তাহলে সিলেক্ট অপারেশন কি দেবে? আমাকে টাপল দেবে। টাপলটা সিলেক্ট করার কন্ডিশন কি? ফার্স্ট কন্ডিশন হবে যে টাপলটা আর রিলেশনে বিলং করে। ঠিক আছে, আমি যে এই দুটো টাপল সিলেক্ট করেছি সেই দুটো টাপল তো আর থেকেই এসছে, এই চারটে থেকেই এসছে, তার বাইরে থেকে তো আসেনি। ঠিক আছে, তাহলে tuple belongs to R and PT means the predicate selection predicate must be satisfied by T, otherwise that will not be selected।
আচ্ছা আচ্ছা, ওকে।
যেগুলো স্যাটিসফাই করছে না সেগুলোকে আমরা সিলেক্ট করছি না। T belongs to R and it must satisfy P, otherwise that will not be selected। বুঝা গেল মানে?
ইয়েস স্যার, বুঝে গেছি।
ঠিক আছে, ক্লিয়ার সবার কাছে? Is it clear to everybody?
Yes sir.
Yes sir.
Okay, next operation is project operation। Suppose in a relation there are three attributes A, B, C, and these are tuples। Okay, now by means of this project operation, the symbol is this pi, we are selecting some column, means some attribute। Select operation is selecting rows, project operation is selecting columns or attributes। Okay, so see there are three attributes. From this, if you want to select two attributes A and C, so see A and C, A we are selecting and C we are selecting, so we are getting a new relation like this। Okay, now see in this relation first row and second row are same, so we have to eliminate duplicate row and we will get this।
Sir,
yes,
someone is constantly messaging in group, they are unable to join and they are giving pictures as well.
okay, nobody is waiting, already 58 students।
They are sending pictures of waiting, but
okay, nobody is waiting right now। And from the beginning, I think I have pressed the admit all button at least 20 times. Okay. So already. So the thing is, see here. What is the problem is some students are just leaving, then at the next time they are again joining. What is the problem? Okay. So see here, what I was telling, that project operation will select columns. So here we are saying the project phi symbol stands for project operations, and A and C, A attribute and C attribute. So we are selecting A column and last column, first column and last column. Those are selected, and after selection, these two, first row and second row, means first tuple and second tuple, will become same. Okay. Now first column and second column become same. So what you can do, we can eliminate duplicates. So now number of tuples become 3. Okay. So this is project operation. So the notation is project, then attribute name, then relation name. Okay. So attribute name means which attribute we want to select. Those attributes only, not all attributes. So here, see the notation, phi operation, phi, then name of attributes, then name of the relation. Okay. So the result is defined as a relation of k columns obtained by erasing the columns that are not listed. So if there are n number of columns, among n number of columns, we can select k columns. So we are deleting n minus k columns. Okay, and then we are building another relation. Now, duplicate rows removed from result, since results are sets. Okay, so in set theory, we cannot put duplicate, means we cannot keep duplicate. So duplicate rows or duplicate tuples can be removed, means duplicate tuples will be removed. Okay, now see, if you do project operation in account relation, so by account number balance, these are two attributes, you are selecting only these two. In account relation, there may be more than these two attributes. Many other attributes will be there. Among many attributes, you are selecting only two attributes. Okay, so you will get another relation. So, any problem regarding project operation? Is it okay for everybody?
Yes, sir.
Okay. Then next operation is union operation. So from the name union, you can understand that we have to combine something. So what we are combining? We are combining two relations. Here input is two relations and output is only one relation. So suppose two relations are like this, A and B, the first relation having A and B attribute, and second relation also have A and B attributes. The first relation name is R, second relation name is S. Then if you do like this, R union S, then you will get this. Okay. So see, first relation, first row. Okay, we are selecting. Second row, we are selecting. Third row, we are selecting. Now we are starting S. Second row, the first row is already there. Okay, this row and this row are same. So no question of adding that row, means duplicate are not allowed. So then last is this beta 3. We are getting this. Is it clear to everybody? Very simple thing. Union operation. I think in mathematics you are aware of union from the set theory.
Sir, দুটো টেবিলের অ্যাট্রিবিউটই সেম হতে হবে এই ক্ষেত্রে?
Yes, the condition is that. Okay, I will say that. So the notation is R union S defined by R union S equal to the tuple where the tuple belongs to R or the tuple belongs to S. So I think this expression is clear. Okay, now for R union S to be valid, R and S must have same arity. So R and S must have same number of attributes. Then only R union S will work. Otherwise, those will not work. This operation will not work. And another thing, number of attributes must be same. And second condition is that attribute domain must be compatible. Means, see, in the table, suppose A is integer type, and here in this table, A is a string type. So in that case, this will not work. Okay, so attribute domain must be same. For A domain of A must match with the domain of this A, and domain of this B must match with domain of this B. Okay, domain must be same, and number of attributes must be same. Okay, must be compatible. I'm not saying same because see, you have seen that some domain can be converted to some type of, sorry, not domain, some type of data type may be converted to another type of data type automatically, and they are compatible with each other. So if so, then this R union S will work. Okay. Now suppose in a bank there is a depositor table and there is a borrower table. Okay. In the depositor table, from the depositor table we are projecting the customer name. So we are selecting customer name. From the borrower table, we are selecting the customer name. Then we are doing the union. So we will get a combined list either from customer name, either from depositor or either from borrower. So a depositor or borrower is a customer. Okay, we are aware of that. So how you can get that? So we are having a separate depositor table and a separate borrower table. From both table, we have to project customer name. We have to select customer name or project customer name. Then we have to combine them. So we can do that combination by means of union. Okay. So is it clear? Union operation.
Sir, there is a question I have. Sir, can the attribute names can be different during the union operation?
Yes.
So in that case, after the union operation, what will be the name?
That name we can give.
Okay.
Okay, suppose here in the depositor table, it is in place of customer name, it may be depositor name. And in case of this one, borrower, it's a borrower name. Okay, then we can combine them and we can give a name customer. Okay, that is also possible. Okay, next operation is fundamental operation is set difference operation. Suppose this is one at relation and this is another relation, R relation and S relation. Now set difference is R minus S. Okay, so R minus S means we are taking R and checking whether that tuple is present over here or not. Alpha 1 is not present. Alpha 2 is present. So alpha 2 will not be here because this alpha 2 will eliminate this alpha 2. And beta 1 is not here. So beta 1 will be there. So here, as a result of R minus S, we will get alpha 1 and beta 1, these two tuples. Clear? Okay. So the R minus S defined as R minus S equal to the tuple when the tuple belongs to R and the tuple not belongs to S. So see, the tuple must present here. So whatever tuple we are getting over here, those tuple must be present here, and these tuples must not be present here. Okay, so that is the condition. Okay, now set difference must be taken between compatible relations. R and S must have same arity. Attribute domains of R and S must be compatible. So same conditions are there, just like in here. Then only set difference operation will work. Otherwise not. Clear? Set difference. Not clear? Repeat. If you have any question, repeat. Not clear to me. Any question? Okay. So next fundamental operation is Cartesian product operation. Okay. So for Cartesian product, we are taking two relations R and S. Okay. Now in R, there are two attributes and two tuples. In S, there are three attributes and four tuples. Okay. So after Cartesian product, we will get 2 into 4 means 8 tuples. The notation is this, R into S. How you are getting those tuples? See, first we are taking all attributes A, B, C, D, E. Okay. Then what we are doing? We are taking the first tuple from R. With R, we are combining all tuples of S. With the first tuple of R, we are combining all tuple of S. So we are getting, see, first tuple, we are getting this. First tuple over here. Then first tuple, second tuple, we are getting this. So in this way, we are getting the first 4 tuples. Then we are taking the second tuples from R, and with second tuples, we are combining all 4 tuples of S. So we are getting last 4 tuples over here. So altogether we are getting, say, 8 tuples by Cartesian product. Is it clear to everybody?
So can this Cartesian product operation take place if the two tables R and S have any common attribute?
Yes.
Okay. And how the result turn out?
But that example I don't have, but I will show that later.
Okay, sir.
So always the Cartesian product is R cross S or sometimes is S cross R.
That will give the same result.
Okay, sir.
R cross S and S cross R will give the same result.
Okay, sir.
And try to memorize, means try to recall one thing, what I have told in the chord rule. It is written that order of the tuples are not important, or order of the attributes are not important in the table.
Okay.
Order of the tuples are not important. If you write the last tuple at the first, that will not change anything in the database.
Okay, sir.
So if you do say S cross R, then you will take the first tuple of S, then you will combine it with 2 tuples of R. Okay. Then you will take the second tuples here, then combine 2 tuples. So order will change, but that order will not affect anything in the database.
Yes. Okay, sir.
Okay.
Hmm.
So the notation is R cross S, defined as R cross S. So R cross S equal to tuple Q. Tuple belongs to R and Q belongs to S. Okay. So assuming that the relation R and SS are disjoint, means nothing is common in between. Okay, disjoint tuple. Okay, if the attributes are not disjoint, then renaming must be used. Okay, see, this may create confusion. Assume that attributes of R and S are disjoint. Okay, see, if R and S having some common attribute, okay, then this definition is not applicable. Okay, now if R and S having some common attribute, then you have to rename one of the attribute. Then after that you have to do this Cartesian product. Okay. So see here nothing is common, means no attribute is common. So we are getting the Cartesian product and this is the definition. Okay, so here no attributes are common. Now somebody asks one question that if there is some common attribute, what will happen? So the answer is, if the attributes are common, in that case you have to rename one of the attributes and then you have to join the Cartesian, you have to do the Cartesian product. Okay. Clear? Cartesian product is clear to everybody? Then composition of operations means we will apply more than one operations. Okay. So see, first in this operation we are doing R cross S, means we are doing the Cartesian product of RS, and this is the thing. Okay. Then from that relation we are selecting rows where A equal to C. Okay, so in the first row A equal to C, so we are selecting that. Second row it is not, so we are not selecting. Third row it is not. Fourth row no, not. Fifth row no. Then sixth row, so we are selecting sixth row. We are selecting sixth row. Then seventh, yes, so we are selecting seventh row. Eighth, no. Okay, so here we are applying two basic operations. First is Cartesian product and second one is select. Okay. So is it clear? Then another operation is rename operation. Okay. What I have told, sometimes we have to rename some attribute. So how you can do that? Okay. So allow us to name, therefore to refer to the results of relational algebra expressions. Allow us to refer a relation by more than one name. Okay. So see, this is the symbol for rename row, then the new name, then the expression. Returns the expression E under the name X. If relational algebra expression E has arity N, then 1 minute. Okay, so if relational algebraic expression E has a arity n, then the rename operation will look like this. Okay, so we have to give n names, okay, for each attribute. Okay, so suppose suppose this is a Cartesian product that you are getting due to this thing, and here you want to do rename. Okay, so row, then you have to give 5 names instead of A, B, C, D, E. Suppose you want to give A1, A2, A3, A4, A5. So you have to write those names over here. Row, then those names, then R cross S. So instead of getting this table, this tuple will be unchanged, but here the attribute name will be A1, A2, A3, A4, A5. So you can give new names. Okay, so these are end of all basic operations in relational algebra. So any doubt, any question regarding this?
স্যার রিনেম অপারেশনটা আরেকবার রিপিট করবেন?
রিনেম অপারেশন কিচ্ছু না, তোমার একটা টেবিল আছে, যে কোনো টেবিল আছে, ধরো এ বি টেবিল আছে, তুমি এ বি নামটার বদলে তুমি এটাকে ধরো তুমি A1 A2 নাম দিতে চাও, দাও, আর কিছু না। সিডি এর বদলে তুমি EFG নাম দিতে চাও, দাও।
ও আচ্ছা,
আর কিছু না। অ্যাট্রিবিউট গুলোর নামটা চেঞ্জ করতে পারো বাই মিনস অফ রিনেম অপারেশন, দ্যাটস অল। ক্লিয়ার?
হ্যাঁ স্যার।
Okay. Now, in my earlier class, I have shown a bank database. Means see previous slides. A year diagram for bank database was given, and if you consider that year diagram, from that year diagram you can follow the rules and regulations of forming the relational model. You will get this relational model. Means these are relations. Okay, these are relations. These are tables. So branch is the table name or relation name, and these are attributes of that tables. Okay, these are attributes of that table. So loan having 3 attributes, depositor having 3 attributes, borrower having 3 attributes, 2 attributes, like that. Okay, so this is a banking example. Okay, and in this example, okay, do one thing, take a snapshot of this. Take a snapshot of this and write it down in pen and paper. Okay, write it down in pen and paper. In the second class, I will take, means I have to go outside. And then I think I will start class around 8:15, 8:20. Okay, so half an hour, 45 minutes is required. Okay, so write down this. Okay, and in pen and paper, and then based on this banking example, I will show some relational algebra operations. Okay, relational algebra query on this. Okay, so how you can get data from tables? That idea you will get. Is it clear to everybody?
Yes, sir.
Just write this page in pen and paper. Just take a paper and write it down. Okay. Now I am ending this class, and 8:15 or this 8:15 or 8:30, within 8:15 to 8:30 I will start the class again. Okay, clear?
স্যার
Yes.
স্যার যখন দুটো টেবিলে অ্যাট্রিবিউটের নেমগুলো সেম হবে তখন যখন অপারেশন দেবো সেটাতে সব অ্যাট্রিবিউটের নামগুলো চেঞ্জ করতে হবে?
না না, তুমি সিলেক্টিভলিও চেঞ্জ করতে পারো, অসুবিধা নেই।
ওকে স্যার।
তুমি বলছো যে ধরো 3টে অ্যাট্রিবিউট আছে, তার মধ্যে একটা চেঞ্জ করবো, বাকি দুটো চেঞ্জ করবো না, এটা জিজ্ঞেস করছো?
হ্যাঁ হ্যাঁ হ্যাঁ
হ্যাঁ, সেটাও করা যায়।
ওকে
ওকে, ঠিক আছে, আমি ক্লাসটা ক্লোজ করছি। হ্যাঁ, আবার স্টার্ট করবো।
ওকে স্যার।
ওকে স্যার।